Hello and welcome to T3 Day 28 of Honors Precalculus. We're going to continue talking about limits and playing around with more fun indeterminate forms and learning some cool algebraic maneuvers. So we're going to say that f of x is indeterminate at a certain x value if when we put c into that value, into that function, we end up with something that's, I'll call it weird, like 0 over 0, infinity over infinity, infinity times 0, or infinity minus infinity. These tell us nothing directly. It's not like they cancel each other out. They can go in different directions. So we need more deterministic, we need more algebra, we need some definitive ways of solving these. You can't assume that 0 times infinity, when they go to war, what happens? It can go either way. Like 0 over 0, weird things can happen. So these are pretty cool. So let's do this first one, because when you try to plug in 5 into this, you get 0 over 0. So what are we going to do? The first thing you check is, can you factor this? And you actually can. This turns into x minus 5 over x plus 1 over x minus 5 times x plus 3. What's really cool here is that the x minus 5's cancel. So now can you plug in 5? You get 5 plus 1 over 5 plus 3 is 6 over 8, which is just 3 over 4, which is pretty cool. So the limit here is just 3 over 4. We say that this limit is 3 over 4, and that's because we factored and canceled. We effectively filled the hole here. Works super well. So what about this one right here? Can we plug in 1 into this? We really can't, because that would be 0 and that would be 0. We don't like that. What we're going to do here is combine fractions by getting common denominators. Well, this is just 1 over x minus 1 minus 2. I'm going to factor here. This is x plus 1 times x minus 1. So how do we get a common denominator here? Well, I'll create some more space here. We need a common denominator. So I'm going to multiply by a form of 1 here, which is just going to be x plus 1 over x plus 1. So what do I end up with here? You end up with x plus 1 minus 2, but now our common denominator is x minus 1 times x plus 1. And what does this simplify to? X minus 1 over x minus 1 times x plus 1. What cancels? Well, the x minus 1's cancel, leaving you with just 1 over x plus 1. Now, what can we plug in? Oh, can we plug in 1 into this? We sure can. So the limit is just going to be, remember it's x going to 1, it's just going to be 1 over 2. It's pretty cool. This doesn't always work, but I'm going to set you up with ones at the beginning where there is some sort of cool payoff like this. So what are the rules we have to deal with here? And these look complicated, but they're generally pretty logical. So for example, if you have k times a function, you can put k on the outside. So you can factor constants out. So take the easy way out here. If you have the limit of two functions added together, you can separate them into two limits, so breaking bigger complicated things into smaller ones is possible. If you have two limits being multiplied together, you can do them as two separate limits and then multiply what you get. And provided that the denominator isn't 0, you can do the limits separately on the top and bottom. These are really important. So when you do something like this right here, you can do it separately, the first limit, the second limit, the third. Sometimes it's overkill, but breaking things apart into smaller pieces can be very, very helpful. So let's play around with some more fun algebra here. We can't plug in 4 here because this would be 0. So what can we do here? Well, we're going to do something pretty cool, which is we are going to rewrite these in really clever ways. So here's the cool observation. X is just the square root of x squared. This is the same thing as this. So we're going to plug that in right here and not change anything. This is a kind of a pro-level algebra tip. So this is the square root of x minus 2 over the square root of x squared minus 4. We haven't done anything. We haven't changed any values. Now the numerator stays the same. You still end up with the limit as x goes to 4 of the square root of x minus 2. But on the bottom, you have the difference of squares. This factors into the square root of x minus 2 times the square root of x plus 2. These two things are the same thing. It's a really cool method. What's really cool now is that these cancel, leaving you with the limit as x goes to 4 of 1 over the square root of x plus 2. Now, can we plug in 4? We sure can. You end up with the square root of 4 plus 2, so that's just going to be 1 over 4. Pretty cool stuff. On this one, you can't plug in 5, because if you plug in 5 here, you get the square root of 9, which is 3. 3 minus 3 is 0. What we're going to do is we're going to rationalize the denominator. what this means is we're going to multiply something that doesn't seem like it's going to help, but it really does. We're going to multiply by the square root of x plus 4 plus 3, the square root of x plus 4 plus 3. This is just a form of 1, so it doesn't actually change the value of the limit. And the key thing here is that the numerator is going to get nicer, and the denominator we're not going to multiply out is going to end up being super helpful. So what we end up with here is the limit as h goes to 5. Remember, keep the numerator the same, so it's h minus 5, and then it's the square root of h plus 4 plus 3. But when you multiply out the bottom, the square root of h plus 4 times the square root of h plus 4 is this, but then you get 3 times that and then negative 3 times that, so they cancel, leaving you with just this. The middle terms cancel, and when you simplify this, this turns into, right here, this denominator right here, turns into h minus 5. And then what ends up happening, you end up canceling this and this. So what do you end up with? The limit as h goes to 5 of the square root of h plus 4 plus 3, just all over 1. Now can you plug in 5? Yeah, you get the square root of 9 plus 3. This just turns into 6. So the cool thing here is that this denominator right here turns into h minus 5, because the middle terms, because of the plus 3 and the minus 3 being multiplied by the square root of h plus 4, cancel the middle terms out. It's a cool maneuver, but this is rationalizing the denominator. So when you see a denominator like this, where there's a square root in the denominator, think to yourself, I might need to rationalize it by multiplying by a form of just 1. So just remember, you can do some creative factoring here, and you can do some rationalizing here, and then you have some limit rules that help you a little bit at a time that can add up to be super helpful. And then if you can't plug in, you sometimes need to add the fractions together or just factor and they cancel.